Hello, this is Mr. Harrison. This video is for my Algebra 1 students. This is Lesson 8.1, page 328 in your book if you wish to follow along. Talking about products of powers, products of exponents. And let me just right off the bat say that we're going to do this lesson in two different sections. Today we're going to cover examples 1 through 4, and the homework reflects those. Right now I'm going to tell you your homework is page 330, numbers 1 through 16. Yes, that is all. I don't normally give all, but I am today. And like I said, that'll cover the first 4 examples. This video may take a while because there are lots of examples here. So if at any point you need to shut it off because you got the concept, that's fine with me. The very first example on page 328 says simplify these expressions. And example 1 is actually 3 different examples. In the first 2, they use the letter X. For reasons I won't go into, I'm using letter A. Theirs says multiply x to the 5th times x squared. I'm going to use a to the 5th times a squared. I'm going to explain what that means, and then we'll see the simplification of it. Whenever I have a to the 5th power, that means that there are 5 a's all multiplied together. 1, 2, 3, 4, 5. And then they're multiplied by 2 more a's, a squared. We know that when we have variables multiplied together like that, we just have to count them up, how many are there. Well, 1, 2, 3, 4, 5, 6. There are 7 a's. We didn't have to draw it up like this. That gets tedious, especially if this had been like 57 and this had been 23. What's the easy way to do it? The powers, the 5 and the 2, get added. 5 plus 2 is 7. Well, that's a little confusing, and people run into this problem often. These 2 variables are multiplied. So a lot of people think that, it's going to be 5 times 2, and they'll incorrectly, though very understandably, put down a to the 10th power. That's just one of those things you've got to get in your head that that's not how powers work. When these numbers are multiplied, their powers get added. An example would be like if I had 10 to the 1 times 10 to the 2. Well, 10 to the 1 is 10. 10 to the 2 is 100. What's 10 times 100? That's 1,000. If you multiplied this, if you went, well, that's 1 times 2, that's 10 to the 2. By the way, this is the incorrect way. 1 times 2 is 2. That's 100. You need to add those. That's 10 to the 3. Here's maybe even a better example. Let's say we had 10 to the 1 times 10 to the 1 times 10 to the 1 times 10 to the 1. Well, if you're going to do the multiplication, what's 1 times 1 times 1 times 1? That's 1. So you're telling me that 10 times 10 times 10 times 10 equals 10? No. 1 times 1 times 1 times 1 does equal 1, but it's not times. When the 10s are multiplied, the powers are added. 1 plus 1 plus 1 plus 1 is 4. So powers get added. Now, the second example, in example 1, shows x to the 5th, and then it has parentheses and a 2 over it. X to the 5th quantity squared. Of course, I said already I'm using the letter A. A to the 5th quantity squared. What does that 2 right there mean? That means that A to the 5th is written twice. A to the 5 times A to the 5. I'm not going to write it out like I did in this first example. I'm just going to use what we learned. When variables or numbers are multiplied, their powers get added. So 5 plus 5 is 10. Now let's do a little shortcut. I didn't have to write down a to the 5 times a to the 5 power. I could have just said, aha, 5 times 2 is 10. Now let's make a distinction here. When I have a to the 5th times a to the 2, they get added. That's a to the 7th. But when I have a to the 5 raised to the 2 power, that's different. That means that's 5 times 2. So a power raised to another power, they get multiplied. If you are confused by that, then write it out as like it says, a to the 5th quantity squared. That means a to the 5th times a to the 5th whole. These two, the 5 and the 5, get added, but the 5 and the 2 get multiplied when they're written in this form. Okay. The third example, in example 1, has this: y to the 4th times y cubed with a squared over it. I'm going to write out what it means. That means y to the 4 times, and they've got it in parentheses. I'll go ahead and put it in parentheses also, y cubed. And that y cubed gets written twice. I can now add my powers. 4 plus 3 is 7, plus another 3 is 10. I have y to the 10th power. Somebody may have said, okay, to show their work, I'll write it over here. Well, this is y to the 4, and 3 times 2, y cubed quantity squared, a power raised to another power. That gives me 3 times 2 is 6. 4 plus 6, I should say, is 10. You get the same answer either way, whether you write it out as what it means, or you do 3 times 2 is 6. Okay, so that's the first example. Technically 3 examples. I'm going to example 2, the bottom of page 328. It says 3x squared times 5x. When you do these, and you have these whole numbers here, or any type of number, coefficients, numbers in front of the variable, in front of the x, these whole number parts get multiplied together. So that's 3 times 5. 3 times 5 is 15. The parts with variables, the x parts, they get multiplied also. So this is 3 times 5, 15, x squared times x to the 1, and we just said that the powers get added. This is 2 plus 1, and I'm left with 15x cubed. Something I need to point out that people get confused with a lot of times. They think there needs to be what's called distributive property here. Oh, it's this 3 times that 5, and this 3 times that x, and then that x squared. Distributive property only happens when there's like a plus or a minus between your numbers within this term. And that is not what's happening here. Just point that out, so I may have confused you more just by pointing that out. But we're not doing any distributive property here. Okay? Relatively simple. 3 times 5, 2 plus 1 for our power of the x. Okay? Top of the next page, example 3, shows this. Negative 8 x squared y z cubed, and then it has parentheses, and it says x, y, z squared. Like that. Is there a distributive property here? No, there's no pluses or minuses in this thing. Well, there's one right there, but that's the front. I'm multiplying, and I could put parentheses around this whole thing times that whole thing. All right? What's the number in front of this x, y, z squared? It's just the number 1. It's understood. We don't have to have it. 8 times 1 is 8. X squared and x to the 1 get combined. 2 plus 1 gives me x to the 3. Do not put 3x. It's x with a little 3 for a power. This is y to the 1, and this is y to the 1. Y to the 1 times y to the 1 gives me y to the 2 power. And here I have z3. It gets combined with that z squared, and it gives me z to the 5. 3 plus 2 is 5. I want to point out that order does not matter. If this had been z squared yx or z squared xy, order doesn't matter. This x and that x would still go together. This y and that y, that z and that z still all go together that way. You could have this answer written in any form, any order that you wanted. You could have the x's first, or the y's first, or the z's first. It does not matter as long as their power stays the same. So there's actually 6 different ways you could write this answer if you started with x or y or z. We won't get into that right now. Oh, and I did forget something very crucial. My answer is negative because of that negative up there. Last example, example 4, at least for today, it says negative AD squared quantity cubed. Be careful with these. Anytime you have a power raised to another power, I encourage students until they get a really good grasp on it to write out exactly what it means. This means negative AB squared. And I need to write that 3 times. Negative AB squared and negative AB squared. If somebody wanted to, they could even say negative ABB, negative ABV, negative ABB. Now this is not minus, this is times, multiplication. So the first thing I'm going to look at is what's a negative times another negative. If you have 3 negatives multiplied together, that gives you negative. If this were an even number, if it were only 2 of them, or 4 of them, or 6 of them, it would end up positive. It goes negative, positive, negative, positive, negative, positive. We have 3. Negative, positive, negative. My final answer is going to be negative. I have a to the 1 times a to the 1 times a to the 1. That gives me a to the 3. I have b squared times b squared times b squared. What's 2 plus 2 plus 2? It is 6. Now we could have done a little bit of a shortcut right here. I could have said, oh, I've got a power to a power. What is 1 times 3 for the A? Well, that's 3. What is 2 times 3 for the B? That's 6. Just don't forget that because this power is an odd number, a negative number to an odd power, it's going to be negative. Negative, positive, negative, you got 3 times. If this had been the number 37 out there, we could do the same thing. I can tell you right off the bat that number is going to be negative because that power is odd. It's 372. That's an even number. I can tell you my final answer is going to be even. That's all there is for now. I will give further instruction on this lesson later, and we will add to this, numbers 1 through 16. You'll be able to put those on the same paper. Just label it lesson 8-1. That's all for now. Hope to see you guys soon. Thanks.